Hi everyone. In this video we will be learning about nonlinear equation, and throughout this week we will learn about how to solve nonlinear systems of equations. So let's first try and understand all these words. A linear equation, you already know, linear comes from line, so it just means a straight line equation. And in this course in week 2 or week 2, we learn how to solve systems of linear equation in 2 as well as 3 variables. And what is a nonlinear equation? Nonlinear equation is something that when represented on a graph is not a line, simply said. But what does that mean algebraically? Algebraically, it means that it is the exponent or the polynomial. We'll be dealing with polynomial type, so that's all right. Is greater than 1. So one of the examples you've seen is y equals x squared. We extensively studied this function, right? We even saw them as not just x squared, but any shifted parabola, and we used completion of squares to understand them, and we saw they look like parabolas. So these are nonlinear examples. Another example is a circle. Equation of a circle is given by x squared plus y squared equals 1. Okay. Now this is an equation of a circle. It's not a function, right? Because it doesn't pass the vertical line test, which is okay. Because right now we're just concerned with what this looks like. This looks like x squared plus y squared equals 1, and that is a consequence of Pythagoras theorem. Because any point you can have a right triangle, and the sum of these is constant. So the goal is here's the actual, like the fundamental goal. When we studied lines, we saw that if we have two lines, right, we have one of three things happening. Either they intersect and there is one solution, or they are parallel and there is zero solution, or they are overlapping and there are infinite solutions. So now the question that we want to ask is, instead of taking two lines, what happens, say, suppose we take a line and a parabola, or a parabola and a circle, or a circle and another circle, or a parabola and another parabola. So these are all the questions that we are going to be concerned with during this course, during this week, the course of this week. Let's take the first one. Let's take a parabola and a line. Now, if you intuitively think about it, what you can do is you can try and make a bunch of drawings and see what possibilities can happen, right? You can have a parabola and you can have a line completely miss it. You can have a parabola and you can have a line touch it precisely one place, or you can have a parabola and you can have it go through 2 points. Other than that, it doesn't seem like there should be any other possibility. So when we solve this, we are expecting one of these. Now, how do we solve? The solving is done by, first, there's method is called substitution, which is again one of the ways in which you solve the set of lines as well. So here what we are going to do is, from the second relation, right? Suppose I add y, then I get 9 plus y is 3x, and then I get y is 3x minus 9. And this, I plug this into the first one. The first one had x squared is 2y plus 10. But now I have y in terms of x. So this is 2 times 3x minus 9 plus 10. This is 6x minus 18 plus 10. Now, what is this? This is just a quadratic. This is a quadratic equation which you can solve using either factoring, or you can use the quadratic formula. And that gives you x is 4 and it gives you x is 2. And then correspondingly, you can find your y, because you know what y is in terms of x. It's 3 times 2 minus 9, negative 3, and 3 times 4 minus 9, which is 3. So the intersection points are x, y, 4, 3 and 2, negative 3, which means that it is this last scenario where there is 2 intersection points. Let's look at a second example. Solve x minus y equals 3 and this equation which says is the equation of a circle. Now what are we gonna do? Again, first let's look intuitively. Circle can completely miss a line, can touch a line at one point, or can go through the line. So we do the same thing here. I get y equals x minus 3 from the first one. And then we are going to plug this into the second one. Plugging this into the second one gives x minus 2 squared plus x minus 3 plus 3 squared equals 4, which is then x minus 2 squared plus x squared equals 4, which is x squared minus 4x plus 4 plus x squared equals 4. That's 2x squared minus 4x equals 0, or 2x, x minus 2 equals 0, giving x is 0 and x is 2. Now since x is 0, y is 0 minus 3. And when x is 2, y is 2 minus 3, which is negative 1. So the points are, so we call them intersection points, or we can also call them solutions, because essentially solution is the same as an intersection point. So these are 0, negative 3, and these are 2, negative 1. So 2 points in this case as well. Okay, so in the next video we're going to learn another method, which is an addition method. Now just to make it clear when which method is useful is if one of the things is a line, right, then you want to go with your substitution method, because there's a reason for that, is that if you have a line, then it's very easy to write one variable in terms of the other, and then you can plug them in. Whereas the next method we learned, which is the method of addition, that's useful if both of your shapes are nonlinear, right? If they are both, say, circles, or they're both parabolas, or they're both some other shape, which we will look at later, which is an ellipse. So that's the particular case. That's it for this video. We talk about that in the next one. Thank you.